probably think I was totally crazy if I told you we have trillions of dollars just floating around in space. Well, hold your opinions, because there are trillions of dollars floating around in space. Now, I'm not talking pieces of paper with people's faces printed on them, or those tiny little metal coins that you use to pay for parking. No, I'm talking something almost just as valuable, and that would be natural resources. So what am I talking about? Well, there are asteroids in space. There are tons of asteroids, actually, and they're all just floating around out there with these natural resources on them. So some of these resources that we have are titanium, which is used in tons of aerospace crafts. We have copper, which is actually used way more than we see. It's in pipes, wiring, even our electronic devices, pots and pans, you name it, there's almost undoubtedly copper in it. And carbon, which can be used from fuel to the tips on our pencils to even treatments for different chemical problems. But unfortunately, you know how you have your refrigerator and as you eat your food, you run out of it. Like, at some point, you're going to have to go to the store and get more food. Well, it's going to be the same for us on Earth. We're running out of these natural resources and fast. And we're going to need to find some way where we can just get them. Right now, it's not about trying to mitigate our losses, it's trying to go out and find more. But how are we going to do that? Because there are 1.9 million asteroids in just the asteroid belt alone. And that's a lot to be sifting through. It's almost like playing the lottery. So if people invest hundreds and hundreds of dollars in the lottery every single year, but there are only a few winning tickets, and that's a huge margin to be searching for just a tiny little result. And many people don't win the lottery. So searching for asteroids is sort of like that, only we need to figure out how to break the lottery and get to the asteroids that are going to give us the money and natural resources we need. And that's where I introduce you to a spectrometer. So a spectrometer is a device that measures the wavelengths of light and chemical composition. And this could go from anything from a candle to the inside of stars to even planets, but we can talk about that later. Right now, let's learn about wavelengths. So wavelengths are a spectrum. So when we talk about the light spectrum, we think of everything we see around us and the light from lamps. But that's not all the light spectrum is. That's only a very small portion of what's visible. So wavelengths can go out so that they're really, really wide, and that's called radio waves. So we use those to communicate here on Earth. And then if you condense them, those are called gamma rays. And you only see those when stars go supernova. They're super volatile and dangerous. So every element on its own has its own special place on the emission spectrum. So that's sort of like how we have signatures. You can't really duplicate anyone else's signature, and we all have our own unique pen movements. Well, it's the same with elements. Every element has its own place on the emission spectrum, and no two are the same. So it's like they all have their own personal signature. So this is hydrogen, and spectrometers can also tell how much of an element there is. So here, there are two readings of hydrogen, both of which show different amounts of hydrogen. So they're measured by lines, which are called Fraunhofer lines. And these lines are sort of placed throughout the spectra so that when you scan something, it takes what's absorbed, and then that's transferred into your spectrometer, and then fed through a diffraction grating, and then it's put into a computer which will change it to the emission spectra we know. So let's work on this on asteroids. So this is the element of copper. So believe it or not, in 40 years, we're going to run out of copper on Earth. And I already told you, it's super valuable. We need copper for almost every part of our daily lives. But in 40 years, we're not going to have it. So what do we do? Well, when we're scanning for copper, say, it has its own place on the emission spectrum. So when you scan something, you hit it with white light, and it will absorb parts of this light. But what it doesn't absorb, it reflects back, and that's taken back by the machine for a more accurate measurement. So by knowing what a certain element is able to absorb, we can tell what element it is and then read it. So you usually would take a reading first on the absorption spectrum, which is just what's reflected back, and then that's translated to the easier to read emission spectra. So that's what we're going to do on asteroids. So I myself have started to build a spectrometer. Now obviously this is not going to be launched into space to take readings on any asteroids, on a satellite or any of that, but it's just to figure out how you can sort of start setting it up to read different elements. So the way a spectrometer works is first there's an entrance slit, and this can take in the light that's reflected back or the light from an inside of the star. And that's taken and it's bounced back by a mirror, or we usually can call it a collimator. So then this is taken and bounced over to diffraction grating. So diffraction grating sort of sifts through the different beams of light and it consolidates to something way more readable. That's reflected by another mirror, and then it's taken and uploaded with a photodetector back to the computer, which a program is able to analyze. So I don't have any of it to show you today, but I am starting to work on building the program at home to really measure different elements and see what I can do. So, as I said, there's money in space, and it's just out there for the taking. We're just going to need help with the finding. Thank you.